Now we have a little bit of time to explore some really big ideas, and so it gives me such a great pleasure to invite some very special people to the stage right now. First up, Miles Skarin, the filmmaker. Tonight we're also joined by solar physicist Miho Janvier. It's also a personal joy to invite the co-founder of Space Rocks, astrophysicist Mark McCaughrean. And finally, and let's really give it up for him, please give it up for Stephen Wilson.
Thank you.
Well, this is such an exciting moment. Stephen, first things first, how does it actually feel to not just listen to your brand new album with such a esteemed company, but also to watch it as well?
I prefer watching it because I've heard it too many times, honestly. No, I mean, Miles has done an incredible job, and to see it on this massive screen is such a buzz, to be honest, yeah.
I mean, it's such a big sound and also incredible imagery as well. I wondered, Miles, if we could just ask you, what was your first thought when Stephen gave you a call about all this?
Well, I remember where I was, and we were looking around venues in London, and I remember you just turned to me and you were like, "Are you up for the challenge, Miles?" And absolutely yes. It's an absolutely incredible honour to be able to be a part of this. And I love space, I love Stephen's music, and so it's just amazing to be able to contribute to the amazing world of visual artistry that Stephen has been able to produce over the years with some fantastic filmmakers and artists. Like, I've got to mention Miho, who's done some absolutely incredible artwork for this piece, and I was able to see all of that while making the film, and it was amazing, just as everything that Stephen's done, so I'm really proud to be here.
Thank you.
Yeah, well, I mean, Miles, it's an incredible visual feat, and Stephen, we know already that so many big ideas also inspired the record as well, and so I mean, they say a picture could tell 1,000 words. So let's start with this one.
This is a couple of weeks ago in the Atacama Desert, and I was very honoured to be invited out to see what will be the biggest telescope on the planet, which is currently under construction, called ELT, which I believe stands for, imaginatively, the Extremely Large Telescope. I think it's still about 2 or 3 years away from completion, but it will be able to see further into space than any telescope before it, and indeed, by definition, also, therefore, further back in time, which, Mark, we're going to talk about that. I think people often forget that it's about time as well as distance, isn't it, when you go out into space? So it was very exciting to be out in the desert to visit this extraordinary location. Yeah.
Yeah, and it's an incredible idea behind all this as well. I wonder if, Mark, briefly, you could give us an idea of why that isn't just a building. And actually, it's only on a screen like this you can actually appreciate the little yellow dot in the middle there. Stephen, I think that's you.
That is me, yeah, with a high-vis vest, yeah.
Yeah. So it gives you a sense of just how big it is. But Mark, what does the ELT actually do?
Yeah, well, the problem with these pictures, anytime you go to a site like this, you end up looking like a complete geek because you have to wear a hard hat and that kind of thing. Same with going into a clean room and seeing a spacecraft. You have to wear a silly hairnet and everything else. Interesting, I've been involved in this project for nearly 20 years already, the ELT. It was conceived as a successor, as Stephen said, the Extremely Large Telescope. It comes as a successor to the VLT, the Very Large Telescope. And actually, the idea at that point, that was first built in 1999, came online in 1999. I was one of the first people to use it, and it's been 25 years, astonishing, because you visited that as well, the VLT. There are 4 of those big telescopes, and each one of those is 8 meters in diameter, collecting area. This, 39 meters across. Not one single mirror, but lots and lots of individual segments. A bit like the James Webb Space Telescope, which we'll talk about a little bit later on. And just collects more light, see fainter things. But, and the key thing about the ELT is that it will use very powerful lasers to correct all of the shimmering that's in the atmosphere, what we call seeing, the thing that makes images fuzzy. So the idea this will give much sharper pictures than any other telescope as well. And that helps you see further, but it sees more detail in things. So yeah, we've been working on this thing for a very long time, and it's amazing to see that it's almost, and you've had, the last time I saw it, it was a hole in the ground. I have a rock, but it wasn't the last time I was there 5 or 6 years ago. It was just a hole in the ground. They actually had to blow the top of the mountain as well. That was an interesting day.
Yeah.
I mean, Stephen, I guess we've talked about why these ideas have intrigued you a little bit, but why do you think it really all clicked with you? I mean, did you have a big interest in space beforehand, or was it just a specific moment in time that just congealed the notion that would eventually become the album?
So the album starts with a meeting with an alien on the moor, and the alien essentially says to me or the listener, "Did you forget about us?" And it's this idea that we spend so much time seeing ourselves reflected back at ourselves through social media, through our phones. We've become very self-obsessed. And I remember, and I'm sure you, and this is one of the conversations we had early on, we remember growing up, spending a lot of time looking up. And not only up, but around us. And I think these days, because we spend so much time looking down into our digital devices and not really being aware of what's going on around us, and certainly not what's going on above us, that I felt like this is the time to try and reconnect with the notion of what I remember being fascinated by as a kid, just going out on a warm summer evening and looking up at the stars and having that kind of curiosity and that sense of awe of looking up. And I just don't think we do that anymore. We're so addicted to our looking down into our digital devices. So although it's a little bit tongue-in-cheek, this idea of the alien saying, "Did you forget about us?" there is a serious message there. And that's really the beginning of the album, and that's kind of the platform, that's the launching point from this journey out into space and ending up on the other side of the cosmos. And that all came to me in a split-second moment during our conversation last year. I had the title, I had the concept, thanks to you, and I heard the music in my head. And I kind of almost saw this piece of cinema for the years that would start on Earth, on the moor with this alien, and end up literally floating on the other side of the cosmos.
Yeah, it was a moment, all right. It was a great conversation, of course. And what we're talking about, of course, was the overview effect. If we'd bring up the next picture, it's an important one because it's all about where this notion comes from. And I wonder if we could shift back to Mark really quickly just to tell us a little bit about what we're looking at there and what the overview effect is called.
Yeah, so this is actually one of the last pictures taken of the moon by humans that went to the moon. This is from Apollo 17. The very famous Earthrise picture comes much earlier, Apollo 8. But this is at the end of the Apollo program, the last mission. And I was looking through the archives recently. I'm writing a book at the moment, Pitch. So go out and buy it later this summer. But I was looking for some imagery that hadn't been seen before and worked from the archives to clean this up. And it reminded me again of that sense of what the first astronauts talked about from low Earth orbit, also from the moon, seeing that little ball a long way away and realizing how insignificant that place where, and channeling Carl Sagan, where all the troubles, all the tyrants, all the emperors, all the people who've ever lived and that we've loved and so on, they all live on that pale blue dot. And I think you said it to me a bit earlier on, and it's quite true. Some people embraced the overview effect as a way of finding almost a sense of perspective. Others got terrified by it. And these are professional astronauts who, they're not, they know what they're doing by being out in space. But that sudden sense that we're a tiny bit in space and that place with that tiny thin shell of atmosphere that we can breathe.
And I think that's what was most fascinating to me about it. Not that the overview effect isn't profound enough as it is, but the idea that people had very extreme reactions, very different reactions. Some people sort of found it a very celebratory moment, and other people just saw death. Famously, William Shatner just saw death, Captain Kirk himself. And I found that fascinating, that there was this very disparate sort of, sort of range of responses. It's almost like, does anyone here remember The Hitchhiker's Guide to the Galaxy and the total perspective vortex? Okay, I'm getting very nerdy here. But that idea that to be able to show someone just exactly how insignificant they really are is almost too much for the brain to kind of engage with as an idea. And we were talking about this before, Mark. Some of the numbers are almost impossible to conceive of, aren't they? For every grain of sand on this planet, there is 1 billion planets in the universe.
Yeah.
I mean, it's beyond, isn't it? Yeah, whatever. Yeah. It's just beyond. And our planet is just one of those. And and like we were talking also about how we've only been here, relatively speaking, for about 5 minutes, on this earth. And yet we somehow see ourselves as the curators and caretakers of this planet. Of course, nothing could be further from truth. And I think all of those things were bubbling along in my head when I was writing this report.
And of course, it's a very visual feat as well, right? You said it's a soundtrack to a film in many ways, and I imagine, Miles, that presented some unique challenges as well. The notion that space isn't just this floaty, wondrous place, but perhaps also a place of darkness, a place of light as well as shade.
Yeah, I think we were talking about this, and that I wanted there to be some sort of scientific accuracy to the visuals. But when I tried to put the numbers into my software, it just said no. It couldn't do it. But also, if you were to fly a camera out into space, what you'd be seeing from all around you would just be black, darkness. You wouldn't see all these wonderful, vibrant images that we see in so many science fiction films. It would just be black until you get to your destination with tiny points of light in the distance. I hope I've got that right, guys.
I think one of the weird things actually about outer space, and Miho, she works on an object that actually has some color and some brightness, but all of the things that you actually see, not only in science fiction films, but in the astronomy images we make, they're almost all too faint to see any color with the naked eye. So if you, for example, flew to one of these bright nebulae that you had in the picture, it would get bigger, but it would never get any brighter. It's a sort of a weird thing to imagine, right? Why doesn't it get brighter when they get closer to it? Well, because it spreads out. It's like the reason when you walk towards a white wall, it doesn't get brighter. Just gets closer, and that's because the amount that it gets brighter as you walk towards it is exactly compensated by the amount it spreads out. So these nebulae are not actually very interesting. If you went out with a naked eye, it'd just be grey fuzz, which is a bit weird. When we show all these glorious pictures, we haven't cheated, but we've collected light for hours and months sometimes to get the colour to come in. So Miho, she looks, because the sun is an interesting object in its own way.
We're going to bring up a really glorious picture as well, Miho.
Okay.
It's one that's very much in your wheelhouse as a solar physicist,
Yeah.
Possibly a stellar object that we take for granted because in some sense we see it every day, but not really like this. Tell us about what we're looking at.
Yeah, so I guess what I thought was really interesting in the video that you made was all these scales. And just to piggyback on the discussions that we just had, I think what's really interesting about the sun is that all you see here, we see the sun globally, but we also can see the sun in very exquisite details. So what you see here is you can see like the bright regions, the dark regions. These are big structures that are megameters. So if you remember, it's the 10 to the 6, which means 10 with 6 zeros behind. And I don't know. Yeah, I think I can see it. At the very top on the right side, I don't know whether you see a little circle. That's so it's not a picture of the Earth with the sun, because we're not that close to the sun. But we have added a picture of the Earth just to show you the scale. So I don't know whether you see it. It's all the way to the top. So I have the light in front of my eyes, so I'm not sure whether you can see it. But it's just for us to comprehend those scales. It's just impossible. But also in terms of physics, in terms of the equations that we're using, in terms of the problems that we are working on, the big difficulty that we have is actually to merge those scales. And we don't know how to do that. We don't have the computers to do that at the moment. So yeah.
And it's also about the change in perspective as well, isn't it, Miho? I mean, it's seeing things in different ways. I wonder, just like in terms of your own personal journey, has your study of outer space, your analysis of the sun, changed the way that you look at life down here on Earth as well?
Yeah, massively. But if I go back to when I was very, very young, I used to be fascinated by life out there. I was a big fan of X-Files. So you kind of go back to, this idea of, is there life somewhere else? And I was fascinated also by big objects of the universe, black holes, galaxies and everything, even though, it's really difficult to understand the scales. And I didn't really think too much about the sun then. And towards the end of my studies, I came across beautiful images from a NASA mission called the Solar Dynamics Observatory. I think I've got a few pictures after, where we can see the sun in all these details. And I never thought about the sun as a star, and us basically bathing in the neighborhood in its glow. And it really made me think why would I want to look at other stars when we have this beautiful star just next to us?
And we're going to bring up the next image as well, which is, again, a different way of looking at things.
Yes, and just to add, my research or study, I don't know if you can see it in the red part here. On the left side, you can see those big giant arcades. So these arcades are actually the seed of what we call solar storms. What they are basically big magnetic bubbles that are expelled in space in the solar system. And if planet Earth is on the way of those big clouds, that's what creates northern lights and southern lights. So I don't know whether you had a chance of seeing some auroras last year. Actually saw some near Alexandra Palace in London last year. But these are basically events that are happening in our sun's atmosphere that are coming towards us, and then they can also impact the planetary, so the space environment of other planets of the solar system. And going back to your question about like whether it makes me look at us or life on Earth in a different way, I would say that for me the fact that we have things that are coming out of the sun that are impacting different planets of the solar system, and now we have the capability to actually monitor this space weather, for example on the surface of Mars, I find that absolutely mind-blowing. And in a way it makes me feel that we are interconnected with the planets of the solar system. And I didn't know that when I started my studies.
Yeah, it's mind-blowing stuff, but I guess it just underscores the idea that Stephen was just underscoring before, which is that knowing about all these things, it does give you a certain idea about, not that we're insignificant, but that we are not the biggest thing in the universe, certainly. And so I have a simple question for you, Mark. How big is space?
Bigger than you can see, and that's a weird way of phrasing the fact that we only see the universe. Stephen mentioned this fact that we're not looking out into space, we're looking back into space. We're looking back in time. Miho, looking at the sun, she's seeing it as it was 8 minutes ago. I'm seeing Stephen a nanosecond ago. We're not actually in the same timeline. He's a nanosecond separate from me, just because it takes light that long to travel that distance. And that's not particularly important inside the solar system because these times are relatively short relative to all the other things that are going on. But when you look out into the deep universe, there's a point to which you can't see any further back in time because there was no universe. Right? The universe didn't exist 13.8 billion years ago, so you can't see any further than that. That's not to say there is no universe beyond that wall. It's there, but we can't yet see it. So every day we see a little bit further into the universe. The universe gets a little bit bigger that we can see. But there is always, and there always has been, much more universe beyond that. So there is no actual answer to that question. There's an observable universe, how big is it? But how big is the actual universe outside that? We don't know.
And I believe we're looking at some of your work right here, actually, speaking of the distances in the universe. Tell us a little bit about this, if we could bring up the next picture as well.
Let's stay with this one for now.
Okay.
So this is much closer to home. This is the center of the Orion Nebula, which is one of the most famous places where young stars are being born. So Miho's working on one star. There's about 3,000 young ones in here, about 1 million years old.
Ours is very important.
Yours is very important because it's close, so you can see much more detail. But what's also interesting is that the stars here are about 1 million years old. So they're actually younger than the Hawaiian Islands, which is, to put into perspective, those places where we study. And I've looked from the summit of telescopes on the mountains in Hawaii. The mountains I've been looking at from are actually older than the things I'm looking at in space, which is weird. But to put perspective in, if you put our sun in the top, right corner.
The next slide, please.
And Alpha Centauri all the way in the other side, the nearest star to us, all that stuff exists in that volume. So this is a very much denser part of the universe. And that particular thing you see up there is a tiny zoom in. You can see where the arrow's pointing. This picture, I love the BFI. It's got fantastic screen, but I think it's 4K wide. This picture is 21K wide, so you can't see all the details at all. But if you zoom in, that is a solar system being born today in this place, in the Orion Nebula, as seen with the James Webb Space Telescope. So that shadow there is actually the gas and dust circling around a young star. And it's blocking the light from the background. It's a silhouette. And it's somewhat bigger than our solar system, so it may shrink down, or maybe it'll form different planets to the one we have in our solar system. We will never know, because we will be dead. We will be ashes and dust by the time that actually makes planets. But we can see planets being born in our own neighborhood. So that provides another perspective that we've been around 4.5 billion years old in time. The sun, to put that into perspective, if the sun was a middle-aged person, these objects are a 3-day-old baby. So they just started their lives, and we can observe that. We can see that from where we are today.
I mean, it's fascinating stuff. And Miles, just if you don't want to give away the full details, that's quite okay. But I wondered if in some of the brief when you and Stephen were formulating what the film was going to look like, whether it wasn't just conveying the wonder of space, but a phrase that you don't often hear, which is also the terror of space. The fact that it's actually, when you think about it, just pretty damn scary.
Yeah, I think that was probably the main challenge I really had in creating the film, because to really convey the scale of space, if you were out there in space, you couldn't do anything if you just were dropped into space. You're so far apart from anything, there's no way back, no one's going to rescue you. And so if I could get that in the video any way, that was my aim. But I think I did really struggle with it, because it's just such a incredible thing to have to try and comprehend.
That's fascinating stuff. And Stephen, congratulations on being promoted to astronaut.
Yeah, I like that bit. That's my favourite bit.
That was a big. Tell us about that. Tell us about that scene.
Well, Miles just said, we're going to put you in the movie. You're going to be an astronaut. So my fear of flying would probably exclude me from the potential of ever actually going into space. That's the closest I'll ever get. But I think just picking up on something Miles was saying there, I think one of the challenges we had when we first talked about this was how can we represent space visually in a way that people haven't seen a million times before. Because I think we are, even though, as I said at the beginning of the conversation, I think we've forgotten about space to an extent because of our obsession with digital devices, we are at the same time very familiar with the visual vocabulary of space. We've all seen science fiction movies, we've all seen 2001, we've all seen sci-fi shows, we've seen the footage that NASA have got on their website. We've all seen that. So I think one of the conversations myself and Miles had early on, and also I had this conversation with Miho when we were designing the record sleeves, how can we depict space in a way that perhaps is a little bit fresher? And I think Miles has done admirably in doing that, trying to reinvent the visual vocabulary of space. We've all seen Interstellar, we've all seen 2001, amazing masterpieces. What can we do that isn't just going to look like a knockoff, So, these guys will be the judge of whether we achieved it or not, but that was certainly something I think we were conscious of. So we went for a slightly more impressionistic vibe. We brought in a lot more personal sort of imagery as well as the space imagery. And I think that's the point, is that this is an album ultimately about human beings. It's not about space. In fact, I was talking about this with Mark earlier on. In fact, there's an argument to say that every science fiction movie ever made is actually not really about space. It's about us and our relationship with space, how we engage with it. It's the kind of existential questions that we ask ourselves in relation to space. But I think particularly here, this is an album about human beings, and it's about perspective, which is a word you've used several times. And I could easily have called the album Perspective. It's not as good a title as the overview, but ultimately it is about perspective. It's about reminding ourselves of our own kind of, fragility and insignificance, and kind of embracing that as a beautiful thing. You talked about the positive and negative thing. I think actually it is a positive thing ultimately to understand that the universe does not give a shit about us. We are completely insignificant, and isn't that a beautiful thing? Enjoy the ride. Enjoy the ride.
Incredibly well said. Well, if we pull up the next image, I can't think of a more appropriate thing to help us underscore just how small we are. Which is this one. So this is a fantastic screen. I'm just going to take a moment to look at it myself. To look at this all on, you still can't quite take it all in. We might need a little guide, Mark, on what we're looking at here.
So you might remember in the 1990s, it's a prog audience, so most of you will remember, right? The Hubble Space Telescope did a thing which was actually seen to be quite bizarre, which was just to point at one location in the sky, a tiny grain of rice held at arm's length, that size of the sky, a tiny piece of it, and look for a month. And the expectations were that you wouldn't see anything, because the universe, we did not believe that recently, just 30 years ago, the universe had lots and lots of galaxies all the way back deep into time, as well as into space. But what that picture showed, it was called the Hubble Deep Field, is that there are galaxies all the way back. And this is a similar image, which I'll describe in a moment, but it's similar in the sense that there are nearby objects, there are a few stars, and I like the fact you picked up on the fact all stars now have to have 6 points, which is the JWST thing, not the Hubble thing. So thank you for doing that. So the things with points are stars. Then there's some big galaxies. There are systems with hundreds of billions of stars. And then some smaller ones, because they're further away, Father Ted effect, right? And then they're further back in time, and you see further and further and further away. And Hubble saw that, and that changed, a huge change of perspective, that all of these galaxies, we could see them. So this is from the James Webb Space Telescope now. And you had to do it a different way from Hubble, because we've mostly heard of what's called redshift. The fact the universe is expanding means that the light from the most distant galaxies is being shifted away from the visible wavelengths. We could never see it. But a big infrared telescope, JWST, can see those redshifted objects. And so we're seeing galaxies all the way back to the beginning of time here, and that's the aim, is how far back in time can we see? Can we see the first stars and galaxies that were born after the Big Bang? Because, as I say, at some point, you run out of things. There wasn't enough time for the light to have come from those objects. It will be dark at some point. What are the furthest objects we can see? And that's in the next picture, if we can go to that.
Next picture, please.
So that's just another one of these little insets. The thing, it's kind of hard for me in the lights to see, but not the thing in the corner, but right in the center, is the most distant galaxy ever seen. It's so far back in time that it's just 290 million years after the Big Bang. And for a while, we didn't think we'd be able to see anything. It takes time for gas and dust to assemble to make stars. So JWST has already seen by far the most distant object, and this is only a few hours. So we're going to be spending days and weeks and months to look. When do we run out of objects? When will we not see anything anymore as we get to higher and higher redshifts?
So how far away is that galaxy then?
That galaxy, well, there's two parts to that. One is that it's almost 13.5 billion years into the past. So you might think that's 13.5 billion light years, but the universe is expanding. So it's actually being dragged away from us at the same time. So it's about 50 billion light years away from us.
But that picture, what we're seeing there, is what it looked like 13 billion years ago.
Exactly the point. It doesn't look like that anymore.
It doesn't look like that
Yeah,
anymore.
I mean, just like all those brilliant pictures on your early albums, you don't look like that anymore. I'm sorry.
God for that.
And so you're seeing the baby pictures. It's like somebody's put the baby pictures of these galaxies in the post and sent them to you, and you're opening them, and you look at them and say, well, that's great. That's what they look like as a baby, but they don't look like that anymore. They look like adults. In fact, some of them might not even exist anymore. So that's exactly the point. They look different to galaxies around us today. They're much smaller, typically. They've got lots of Orion nebulas inside them making baby stars. And so from that, we can learn how galaxies got made over time. Our Milky Way didn't emerge into the universe as a thing. It's been assembled over billions of years. And we can now see it happening by stepping through the data, looking at different distances.
It's a lot of facts and some very significant numbers as well. Miho, you've spent a lot of time on stage communicating things about your research, trying to get these ideas across. What's the biggest challenge as a solar physicist, or indeed what a lot of people just call an astronomer, rightly or wrongly, when you're trying to communicate these big thoughts as well as all the big mathematics that I think for a lot of people like myself, it just washes right over your head?
I think one thing that I'm trying to convey the most is that we are humans. So I think a lot of people come with this preconceived ideas that scientists are a little bit, bit too rational, and they don't necessarily have emotions. And I think that's something that I'm really trying to say, that researchers, scientists, they really are driven by a certain passion and a certain emotion. And all we talk about, it really resonates with me. Whether we're talking about the terror of space, for me, it's more like a marveling at space and the things that we're able to do. And for me, that's maybe the most difficult, but the most rewarding. If I can tell you how much I am amazed by the things that we can do and the things that we discover, then that's my job done when I do that.
I think just to follow up on that, the key point is you pay for everything that we do, right? We're civil space, we're government space. The UK is part of the European Space Agency, which Miho works for. I retired last year. You pay for all of this, so we have to come and tell you about it. Maybe not in this venue, maybe a different venue, maybe other ways. Because, as you say, we got into this because we were little kids. We watch the same films you watch when you were young. We went this way, you went that way, but we're not in different universes. We're looking at it from different perspectives. And so I think that's a great thing about Space Rocks. I mean, Alex does have the shirt on there, which is good. is that way of bringing music and science and so much else together.
If I can just add something, well, it's my, how to say that, it's selfishly something that has amazed me over the past few days. So almost exactly 7 days ago, the mission that I'm working on, it's a small robot furling through space called Solar Orbiter. And a week ago, we passed by Venus and very, very close to Venus, so 200 kilometers from the surface of Venus. And we used Venus in order to get into another trajectory. And for the first time in the history of humanity, in a few weeks' time, we're going to have a view of the poles of our star, the sun. We've never done that before. And I guess that's the difficulty that I'm trying to convey. Difficulty in terms of trying to convey that this is something that we are all doing. It's not just the scientists, it's also the public participating in that adventure.
Absolutely. Well, I suppose we have Stephen to thank for bringing us all together to celebrate these concepts. And also
no, on the contrary, Alex, it's all your fault. In many ways, that's true, sir. Yeah.
I was present for the salad, and the conversation went from there. But no, it's joyous to hear you say that, of course. But these are things that I think are pertinent to all of us. And I remember at the very genesis of when I began to really think about space in a different way. There's a wonderful book called Moon Dust by a journalist called Andrew Smith, who tracked down all of the surviving Apollo astronauts, and he lamented this fact that not many poets or artists had actually been into space, and therefore they couldn't really communicate what they had seen. And I wonder, Stephen, if in some sense what you're doing is doing something even better, because you've spent so much time interacting with the information, with the results of science and all that, to create something very much like that. So a final thought from yourself on what you hope people will take from this record.
Well, I approached it in the best possible sense of the word. I approached it like a bit of an idiot. I didn't go into scientific rigor. I didn't sort of find it. I just approached it very much from a human perspective, like gazing up at the Earth, being aware of the sheer magnitude, size, in terms of distance and time, all of these things. How does that make me feel? How does that reflect on the way the human species is evolving? And one of the big things for me is during my lifetime, I have seen the human race evolve in a completely different path, in a way that perhaps we haven't had such a shock to our evolution any other time in the history, the 300,000 years we've been here. This is the most shocking, rapid change of evolution we've experienced since the beginning of human species. And it's down to technology. It's down to digital devices. It's down to social media. It's changed the way we think. It's changed the way we engage with other people. It's changed the way we engage with the Earth. It's changed the way we engage with the environment. Those things fascinate me, and you can go back right through my albums and you'll see that fascination manifesting in many different ways. The Future Bites, particularly, was an album that was very much about how we engage with technology, Fear of a Blank Planet. And I think this is the first time I've looked at that subject in a more kind of cosmic way, which really, so I could argue that everything was leading to that, to actually see the human species through the prism of everything, through that sense of perspective. And I hope people will take that, but I hope they'll also take it as a beautiful thing as well as a scary, because that's our very first conversation. We talked about that. It's beautiful, but it's also really scary, and it's death in the nicest possible sense of the word.
It's also a very beautiful thing. We could go on, and I think the conversation will continue because it's one that you have provoked, Stephen. So please give it up for this man and for Miles for bringing us all together. The album is out on March 14th. Thank you so much, everyone, for your wonderful time. It's a joy to be here. Thank you.
Well, thank you, Alex. Thank you.